We good? Okay, cool. Hi, everyone. Thanks for coming along. I hope everyone's had a good conference so far. Excuse my slight sweatiness. I realized I was missing a power cable, so I had to run to the nearest elk job, which I do recommend. It's awesome. But yeah. So I'm here to talk about what I call reactive infrastructure. I'll go into some details about that. First of all, introductions. I'm Piers. I'm a solutions engineer at Pulumi. That's ways you can kind of get in touch with me, Twitter, email. That's my GitHub repo. I'll put the slides on there. There's also going to be a demo at the end, and I'll put the code up there as well. So very quickly, Pulumi, for those that don't know, is an infrastructure as code tool. It allows you to use common programming languages to define your cloud infrastructure. And what this means is that you can use kind of standard software engineering practices and tools to deploy infrastructure and applications. So this is what the Pulumi ecosystem looks like at the moment. And because you're using these common programming languages, so Node, Java, Go, Python, .NET, and more recently YAML, if you call that a programming language, because you're using these, it means that you can use common programming tools, so you can use IDEs, and you get all the nice IntelliSense that you would get from writing any kind of TypeScript application, for example. You can use testing packages, so you can actually test your infrastructure, unit test it, run integration tests, and that kind of thing. And obviously CI/CD tools that you would normally use to deploy your applications, you can use to deploy your infrastructure using Pulumi. So I want to start by talking about kind of metric-driven infrastructure changes. We all rely on using metrics from our servers, from our applications, and so on, to make changes. Horizontal scaling is the usual way that people do this, because it's kind of the easiest and quickest way to add capacity. And there's a few ways that you can use metrics to do this. So one is this idea of adding web servers behind a load balancer. It's something that pretty much everyone does. So the idea is you scale up automatically based on CPU, network I/O, memory, and it's a pretty good way of ensuring that your application doesn't stop working because it can't handle the number of requests being thrown at it. The hardware is in quotes, because if you're automatically scaling like this, then it's more than likely you're in a virtual machine or container, so not actually accessing the actual hardware itself. Message-based scaling is another way. So you have workers processing messages from a queue. This is another good example where horizontal scaling is used. The metric here is the number of messages on a queue. So if there's more messages than the workers can handle in a given amount of time, there may be consequences. You know, orders don't get fulfilled in time. Emails go out hours after they're supposed to. And so in this case, we kind of add more workers to read those messages. And then the number of messages goes down, and then after a while we can remove those extra workers and save money. And some cloud providers obviously do this automatically. For example, AWS Lambda, they add more containers to handle all the events and messages that come in without actually you doing any extra work. So event-driven architecture, so I mentioned in the blurb that it's kind of taking this reactive infrastructure is taking ideas from event-driven architecture. So this is where you have multiple systems or services, and they don't directly interact with each other. You might hear the word decoupled used a lot. First of all, let's flip this around and look at what's not considered event-driven. So usually based around sort of synchronous request-response calls, so more of the client-server relationship. Client sends a request, waits for a response from server. This might be a two-way thing, so the request might go each way. And then if there's no valid response or the server is taking too long, then the client, it might cause kind of issues upstream from the clients. So in this example, you've got the add user service makes a request to the send email service. You add a user, you send an email. It's quite a usual kind of workflow. And then has to wait for the response before writing to the database. If something goes wrong, like there's a bug, or there's a problem with the network between the client and server, there could be any number of issues, then the request may not be fulfilled successfully and therefore cause problems. So event-driven architecture, it uses events, or messages, commands, notifications. I'm kind of using all these words interchangeably here, which I'm pretty sure is going to make someone to kind of twitch uncontrollably at some point. And they use these to trigger communication between the services. An event is usually created when something has changed. So user's been created, an order's been placed, all those kind of things. And usually there's some kind of messaging infrastructure between. So it's usually over a queue or some pub subsystem. And if you're using the cloud, you probably use something like SQS, SNS, EventBridge, Google PubSub. Is your event bus? No, is your message bus? I can't remember which one it is. You'd use one of these because the cloud provider has kind of created these. They're highly available. And why wouldn't you? So in this example, here a new user has been added. So a new user event is triggered. That's then put on the queue and picked off by one of the workers. They, in turn, then trigger another message, which kind of like to send an email, and then the send email service will pick that up and send emails out. So the event producer, so in this case, the add user service, at the top, probably doesn't have an expectation that the event will result in an action. It just goes, a user's been created, do something. In fact, probably not even do something, it's just a user has been created. So it's not waiting for a response from that an email has been sent. You may require that, so you may have kind of a queue going in the other direction. So the add user service might also be a worker that's then listening to an event that says, yes, I've sent the email. So why would you do this? First of all, you're protected against the server having issues. So in my earlier example of the synchronous architecture, if that send email service goes down, then the add user service might have issues. Obviously, there are things you can do to protect against this. You can use circuit breaking, throttling, all those kind of things, but it ruins the point of my talk. So if the add user service is just writing to a queue, and that queue is highly available because it's SQS or whatever, then if the send email service stops functioning, the messages are still on the queue, and then once it starts again, the workers will just carry on where they left off. So that that's where this kind of idea of a blast radius is kind of happens. You don't get as much blast radius. So the more efficient scaling, since you don't have to worry about the capacity downstream, as long as the queue system holds out, then you can scale up the upstream services to handle whatever load they're dealing with. So if you're getting lots of users being added, it's not going to affect that send email service because all the messages going to a queue and they're just ticking away, processing those, sending the emails out. Assuming that, of course, the queue doesn't get, I'm not going to say full's the wrong word, overloaded, because, and then it's going to take a long time for those messages to get sent out, those emails get sent out. However, then you scale up using, because you've got those queue metrics, you've got the number of messages on a queue, so you can scale those workers out should you want to. And the reason that more messages going onto the queue is not going to affect the stability of the workers is because the queue's a buffer. So if your downstream services aren't becoming overloaded and they are just gradually working through those messages, then you can just leave the number of workers as they are. I'd say if you want to scale up, so make sure that everything gets sent in a good time. If the time is an issue, great. If not, they'll get to them eventually. And then the agility. So if you want to add a new service to this, so you want to have something else that's listening to that's going to work from that add user message, you add it in. The add user service doesn't care. The send email service doesn't care. You're just subscribing to that same message. So assuming you're using some like publishing subscription service, yeah, no, it doesn't. Those other services don't care about this new service, so you can just go ahead, add them in, and it shouldn't affect the rest of the system. So what if you could make changes to your infrastructure based on those discrete events that are produced? So confession time first. When writing this talk, I realized that there are actually some ways of doing this that go against the tenets of event-driven infrastructure. So everything I've just said is something you can do, but more often than not, you won't. Hence why this is not called event-driven infrastructure, but rather reactive infrastructure. I will also point out that I've completely made up the term reactive infrastructure, so as a name for this concept, so remember you heard it here first. And also, it turns out if you Google it, you're going to get a lot of results around reactive programming or the React framework. So I've still got some SEO work to do there. So let's talk about what's not. Okay, so this is something I've made up. This is what I would not consider reactive infrastructure. So these I keep thinking there's a screen here. These two methods are kind of how most people deploy infrastructure at the moment. So GitOps is, you make some change in a tool like Pulumi or Terraform or CloudFormation, you push it to your source control, probably Git, and then that triggers some CI/CD tool. You may even do ClickOps, so literally pointing, clicking in the cloud provider's administration tool. Now, some people judge on that. It is 100% a valid way of deploying infrastructure. If you want to go and point and click because you find it the easiest and it works for you, do it. However, it can be prone to mistakes. So if you do this and don't want to, I'm hoping kind of everyone here does some like infrastructure as code kind of automation. But if you don't and you want to talk about it, I'm going to be around for a few hours afterwards, or if you're rushing to catch a plane, you can email me. So this is actually how I'm defining the term. So reactive infrastructure, changing infrastructure by reacting to an event or signal from another system. What does this look like? So your source emits an event. It may be PagerDuty. So you PagerDuty, you can configure PagerDuty so it sends out an event, a webhook, or something like that. It may be that a new customer has entered their credit card details for your SaaS and started paying for your service. You may want to build infrastructure on that. You may have a multi-tenanted service that you then need to go and deploy because they've paid money. You may also want to trigger changes based on the resources you've already created. For example, if you use something like Tailscale or StrongDM or similar, and you want to add your newly created Kubernetes cluster to one of those services, you can do that as well. And depending on the source, this might be an HTTP request to webhook, which is the whole why it's not event-driven. Or it may be use something like EventBridge or Google PubSub or something like that to push the event. So some of those there are some like sort of third-party services that do use EventBridge. For example, PagerDuty does, Stripe does, Auth0. So if you use any of those, you can actually push their events into EventBridge and then use them from on there. For those that don't, you'll probably have to set up to receive the set up a webhook so that you can receive an HTTP request via an API gateway or similar. And then the deployment is kind of where it gets interesting because you'll want to build some kind of application that handles the messages to respond to the HTTP request. So you could build something that uses one of like the cloud provider SDKs to change your infrastructure. You could use something like Terraform exec. Again, valid option. I found it a bit restrictive because it's only in Go. I've got nothing against Go, but there's other languages that Pulumi supports, for example. And it's nice to have a wider range. And then, so you could use Pulumi's automation API. So automation API is a programmatic interface for running Pulumi commands. Running Pulumi programs without actually running the CLI. So it's basically a wrapper around the functionality of the CLI. And what that means is you can embed it into web services APIs. You can even build your own CLI that uses automation API to wrap around the functionality of the Pulumi CLI. If you want to actually, some of my colleagues have done really successful proof of concepts with that. And it also allows you to build custom workflows on top of Pulumi. So you can actually, rather than kind of orchestrating different different updates as different steps in the CI/CD, you can actually run multiple updates from kind of one application and kind of build out your infrastructure like that. So I'm going to do a demo. It's going to involve the automation API. So the story here is that we have customers that sign up to our service. And for their well-earned cash, they get a custom S3 bucket with an HTML file in it and contains the text of their choice. It's nothing special. I'm not going to show you how to kind of build, like what resources you need to kind of build API gateway to Lambda to whatever, because that's not what you're here to see. So I'm just going to do a very, very sort of simple demo. Going to build the API. There are fake payment provider. It's going to make a request to whenever payment is made. So the payment provider, whoever that is, makes a request to a webhook to say that the customer's paid. I've built this in using the minimal APIs using .NET 6. So that's going to include the Pulumi automation API, and we're going to use that to define our resources in AWS. So, cool. Okay, so I've got a very basic, let me make this a bit bigger. So what I've got here, it's a very basic kind of setup to minimum API. We're going to have 4 endpoints. So we're going to do a post, a get list, a get item, and a delete item. So at the top, I wouldn't normally suggest use regions, not particularly nice, but just to hide like all the standard Swagger and minimum API setup. I've got a couple of logging methods, project names, so I'm going to use that in many places. So the first thing we need to do in this is create what's called a workspace. So a workspace is kind of like the Pulumi context. It normally has one Pulumi project. So a Pulumi project is is your code, basically. It's your resource definitions. And the workspace is the context of one project. It may have multiple stacks. Stacks are environments that you deploy your Pulumi program to. Think of them as environments, so they may be in the same account, they may be in different accounts, they may be in different regions. For this case, I'm going to have one project and multiple stacks, one stack for each website, and I'll show you how we can call them later. Yeah, of course. Better or bigger? Yeah, thanks. Cool. Okay. So I've written all this code. I've got snippets here rather than you watching me make loads of mistakes. So the first thing I'm going to do is create the workspace, which, as I say, creates the workspace. We've got project settings, and then we're installing the AWS plugin. So as I said before, what this is actually doing is it's running Pulumi. It's a wrap around the CLI, and it is actually running the CLI behind the scenes. I'm running here what's called an inline program, which means it's part of the code. You can run a standard Pulumi project. So if you run Pulumi new, you'll get a Pulumi new AWS TypeScript. You'll get a Pulumi program that will allow you to deploy an S3 bucket to AWS there. It's a template. It'll set up for you. You can have that in a separate folder and actually target the automation API at that. But in this case, I'm running it inline, and I'll show you the resources and how I'm doing that in a minute. So I'm installing plugins, doing that. Then the next thing, I'm going to set the stack config. So here I'm set it saying deploy this to EUS1. Because it's code, you can set this anyway. You can grab this for environment variables, however you want to. And then let's start with the post. Let's create a site. First of all, the first thing I need to do is create the Pulumi program. So I'm going to scroll right down to where it is here. So a Pulumi program, if you've done anything with Pulumi before, it'll look very similar. If you've not done Pulumi, but you've done Terraform, a lot of the resource names will look very similar. But yeah, so and kind of the structure will look very similar. So first of all, we're going to create a S3 bucket. We're going to have it as a website, and we're going to have the index document as index.html. pretty standard. Then we're going to create a bucket object. So this is going to be the index.html file in the S3 bucket. You'll notice that so bucket, I'm pointing at the website bucket. So I don't need to kind of know what the name is in advance or anything like that. I'm just going to create one. So the bucket, you'll notice I'm calling site name. So whatever I call the site, it'll have that as the bucket name. And then because I don't know what's that necessarily going to be, we auto name resources, because then you kind of don't get, like S3 is all the buckets need to be globally unique. So if all the buckets are called Piers, all the buckets called Pulumi, you're going to have problems. So we do bucket name hyphen random characters afterwards. You'll see that in the bucket name later. But because I don't know what those random characters are going to be, I need to point the bucket kind of property of the bucket object at that variable. The content, you'll see I'm actually just grabbing from the function parameter, the method parameter. I'm calling it index.html, and I'm saying I'm uploading it as HTML, because otherwise you won't be able to you want to serve it up as HTML content. So the next couple of bits are the kind of the slightly less interesting bits. So first of all, I'm defining a bucket policy. So you can see we've got the policy here. So it's allow AWS doing the S3 get object, and so we take it. So we've got an on. I'll show you how we get that in a minute. And we're just saying get. So this is basically get all the objects in that S3 bucket. So we've got the on. So what I've done up here. So website.on is going to be, when we create the bucket, it's going to have an on. That's the like the resource name that Amazon gives it, Amazon resource name, I think. So, but because we don't know what it is yet, at this point in time, the bucket doesn't exist. We don't know what it's going to be. So what we need to do is use what in Pulumi we call an apply. And what this does is it says, once you've got it, you can run this code. Once you've got that ARN, you can run this code. And all we're doing is creating this policy document from that. If you've used Pulumi, you'll know that apply or outputs, inputs are some of the trickiest things in Pulumi, because of the way it's kind of all like asynchronous, especially in things like JavaScript, because it's asynchronous and you basically have to go with it. Again, if you have problems with this later on, give me a shout. Or we can talk about it afterwards. But it's basically, think of it as a promise in JavaScript or TypeScript. It's basically a promise. So that's the policy document. Then we're going to create the bucket policy. Pretty standard. And then we're going to grab an output. So what this means is when the Pulumi program is run, it's basically like a return statement. So when the Pulumi program runs, I'm marking, in this case, it's going to be the website URL, so the S3 website URL, mark it as an output so I can access it in other places. If you're using just a normal Pulumi program, you can get it by doing Pulumi stack output, output name. Because it's here, we can use it and actually access it through a variable later on. But it looks like that. So it's basically a dictionary. Okay. And you see this is the bucket, and it's the website endpoint of the bucket. So far, not hugely exciting. So then we're going to create a stack. So as I said before, a stack is an environment for the deployment. I'm setting the config, so I'm setting it to EUS1, and then I'm going to run the equivalent of Pulumi up. So this is running up the up. It's taking that output that we had earlier from the dictionary and putting it into a variable, so that then I can, instead of calling results.ok, I can call. I can actually return something useful. So I'm just going to comment this bit out. So I'm just commenting some code out so that I can then run this and I can show you what's going on. So I've already logged into Amazon with my SSO login, so I don't need to do that again. So if I now build this, hopefully that's going to build. Cool, okay. And then if I do run, so standard program, it's running on port 8000. I've set up Swagger because that's useful, which means then I can go into here and I can refresh this, and I can run a post. So I can, I could run curl, but I'm going to do it here. So if I just call the name Piers and I do hello Oslo, and then run this. So whilst that's running, I'm going to go back to here, and you can see here it's running Pulumi kind of messages. So it's outputting Pulumi messages to the logs, in this case the screen. So it's creating the bucket, it's created the object, it's uploaded the object, it's created the policy, and here you go. You can see here we've got the website URL. So so that's the bucket name. So Piers, the name of the site. There's the auto naming that I was talking about. So that suffix, and then you've got the standard S3 website URL. So what that means is I can actually copy and paste this and pop it in here, and you've got hello. That's not right. That's the one. And you've got hello Oslo. So yeah. So we've taken there. We've created a Pulumi program. We've defined our infrastructure, defined our S3 bucket. We've uploaded the content as a string to the bucket, and it's given us an output, and it's given us the website URL. And that's all very well, but actually it would be more useful to kind of run other things as well. So let's now look at let's see a list of the sites we've created, because you've got a user coming along, they want to see all the sites they're paying for. Let's give them that list. So all these calls actually call some. So the non-Pulumi up ones are actually calling into our Pulumi service. If you want to know about the Pulumi service, I can talk to you about afterwards. But it's basically a way of managing your state. It's a paid-for thing that we offer. But that's what this is doing. So this is going to list all the stacks. We're going to loop through those, and we're literally going to add them to we're going to get the outputs, select the stack, get the outputs, and then add them to a list, and then return the list. So again, a pretty standard application, but in this case, you can then go and see we've had the post. So the post would be the one that webhook that the payment gateway, whatever, would call, and it would create the site based on input from the user. But then we can also use the automation API to actually build the rest of the application. So that's running. So we can go back to Swagger. We can do sites, execute, and then we'll get a list of the sites and the information about it. Okay. So yeah, so there we go. You can see, make that a bit bigger. We've got the site name, we've got the website URL. You can also do kind of a sort of a get site as well, but the main other one I'm going to do here is a delete. So, go to my code. Let's do the delete site. So this is going to be if they're not paying anymore, whatever, you delete it. This is going to actually destroy it. So this is going to tear down all that infrastructure. So this one will again show Pulumi output in the logs. So if I then, all I've done here is I've added the code. We're going to again select the stack that we're working on, go and destroy it, and we're going to delete the stack to tidy up after ourselves. So this line is actually destroying the infrastructure. This is the line that deletes everything from Amazon, and this just tidies up after ourselves in the Pulumi infrastructure. Try it out. name is Piers. Run this. Again, you'll see it's running Pulumi code, deleting everything. So it's deleted all the infrastructure. It's going to go ahead now and delete the stack there. So if I go back to my, the bucket's gone, code's gone, customer's gone away, we're done. Yeah, so that's the demo. So a couple of other things that I wanted to mention. So if you're interested in Pulumi, if you want to learn more about Pulumi, we're running a couple of cloud engineering days, free virtual event on the 2nd and 3rd of November. QR code for the link. If you want to know more about, yeah, so we're doing demos, we're doing hands-on stuff, hands-on workshops, we're doing best practices and all those kind of things. There's also a hackathon. And then I'm doing a workshop on the 3rd at 4 p.m. Again, free on serverless architecture on AWS. If you're interested in registering, that's the QR code for that. Yeah, thank you very much. If anyone has any questions, I will happily answer them. Otherwise, yeah, thank you for coming, and I hope you have a safe journey home. Are there any questions? If not, yeah.
I kind of wanted to pick on one thing that you said about GitOps, and
yeah.
I think you can really organize GitOps in a way that it kind of only describes the types of objects and really kind of not put any information on the number and on the numbers and sizes of things, and uploads it purely to kind of current state in the cluster from the GitOps repo. Or do you disagree?
No, I don't disagree. You can do all this in GitOps. What I'm kind of, and again, absolutely valid. You're not going to use the reactive stuff for everything. So sorry, the question was: is GitOps still valid? Basically, you know, you can do a lot with GitOps. Yes, it's 100% still valid. And I would never say do this for everything. This is where you want to control your deployments based on, as I said, outside influences, outside services. So for your basic setup. So your base setup, so your VPCs, your base applications, your Kubernetes clusters, all those kind of things, 100% use GitOps. Yeah, still carry on doing that. Deploy it using CI/CD. Have those kind of manage the review cycle, everything like that, to make sure you got it right. But then you have the opportunity to also update it based on input of another application. But yes, GitOps is, so I would use this in combination with GitOps. I wouldn't just use this. This is it's a combination thing. Anything else? Yeah?
How would you manage state for these stacks that you create?
Great question. How would you organize? How would you manage the state? So if you're using Pulumi, you'd manage the state in the same way that you would manage any other Pulumi state. So you can use the Pulumi service, you can use S3, Azure blob storage, Google file storage, or local file system if you want. You'd manage your storage in your state storage in exactly the same way. So when I was doing this, my state was stored in the Pulumi service in exactly the same way. So I have a project, and each stack has kind of its own state. And I'm just updating the state of that one stack within the project, but it's all stored in the cloud, in the Pulumi cloud service. But yeah, exactly the same way as you would store the state of any other Pulumi project you're using. Anything else?
Well,
oh, yeah.
Since we've got quite a bit of
yeah.
still left, because I'm quite new to Pulumi. I used to kind of work Terraform, which I guess is much more declarative,
Yes.
while Pulumi is totally kind of imperative programming kind of thing. That's how it looks like.
Yeah, it is. There's some great blog posts. In fact, there's a very recent one on our site. So the comment, I know you got a question, but so the comment there, declarative versus imperative. So yes, you're using imperative programming languages, but because Pulumi builds out this declarative graph under the hood, it is technically declarative, but you're using Turing, imperative language to define it, but you're defining what goes into that declarative state. Carry on.
So you're saying that I can kind of run this Pulumi program and then take the output of it to actually...
Yeah. So we have a feature that's what is it called? Pin to preview. So the idea is that you can, if you're running Pulumi up, you can run Pulumi preview with I can't remember what the argument is, but you can set another argument, which is basically output this as a JSON file, and then you can use that the same way you would a Terraform plan. So in the exact same way you Terraform plan, you'd then apply the plan. You can apply the output from the preview, and you can do that. So yeah, you could totally do that. Carry on.
What's the kind of state of support for different cloud vendors currently with Pulumi?
Pulumi. So the big where is it? So the question was about support for cloud providers. We support all those providers. So the big three, Amazon, Azure, and Google Cloud. Azure, we support the ARM templates, as in we basically scrape the ARM templates and build out the SDK from that. AWS, currently, we cover the same endpoints as like the Terraform provider, but we are working with Amazon on their Cloud Control API, and so we're going to have a new, so once that's kind of all rolled out and they've got all their resources on there, it's going to be comparative with that. So you will have access to everything in Amazon, and when it gets released into Cloud Control API, it will be released within a few hours to Pulumi. Kubernetes, we scrape their Open API spec. So when a new version of the API comes out, they update their Open API spec, and we scrape that and build the SDK off that. So it's a one-to-one mapping. So we are normally a couple of hours behind it because it takes a little while because everything's in Go. We have to run all our automated testing. We then have to do releases in all the different CPU architectures and stuff like that. So it takes a couple of hours, but we'll have it out in a few hours. In fact, once actually we were slightly ahead of the Kubernetes API because they made a release and then rolled it back, but they told us that they were going to roll forward again, so we just kind of left it. So we were actually ahead of the. we were very prophetic in that sense. So we were actually ahead of the Open API spec at the time. But yeah, we support all these. If you have a problem, if you've used anything, you have issues, please raise an issue. Email us support@pulumi.com. Yeah. Was there one that you wanted to see?
Maybe then one last question. Like
Yeah.
The business model of Pulumi, how much of it is kind of just open source and free to use?
The CLI, all the providers, automation API, that's all free. That's free, open source. If you go to github.com/Pulumi, you can see we develop in the open. We accept PRs from people that want to update it. The paid for bit is the service. So if you want to use us as state management, we have things like in there we have like a secrets provider. So all your secrets are encrypted by default. Certain other similar infrastructure as code tools I won't mention. If you look at the state file, even if something's marked as a secret, you can see the decrypted value. You can see the plain text value in the state. With Pulumi, that's not the case. So we have a secrets provider, or you can use Amazon's KMS, HashiCorp Vault, any of those kind of things, Azure Key Vault, and whatever the Google equivalent is. So you can use those if you want to bring your own key. But yeah, so that's in the service. SSO, RBAC, so you can control who deploys what stack to what. If you think of a stack as an environment, so you have your dev stack, your staging stack, and your prod stack, you can say everyone could deploy the dev stack, which is your dev environment, but only the CI/CD bot, which has its own access token, can deploy to production. So you can gatekeep on that. We also run policy as code. We have policy as code tool, so you can write policies in Python, TypeScript, or Open Policy Agent, and define policies to block deployments before they even hit the provider. And if you pay us, you can do that automatically. Basically, so that's the business model. We have
It's general support, I suppose, right?
Oh yeah, if you're using Pulumi, we'll support you. We'll help you out. Obviously, if you pay for it, you can get more things. You can get private workshops. You can get extra help. But we will always support you. We're there for our users, be it whether they pay us or not. We will help them because we want you to succeed. And if you start to succeed, it may come a time where actually you want to pay us because you want to use the service, because you don't want to manage your own S3 buckets and all the iron roles that you need to make sure no one has access to it and all those kind of things. Yeah, so we're kind of looking at the long game there. Anything else? You're done. Cool. Okay. Well, thank you very much, folks. Have safe flights home if you're leaving the country, or driving home if you're not.